Hello good people, I am going to talk about atomic symbols. So far, when it comes to atoms and subatomic particles such as protons, neutrons and electrons, I have been using colored spheres. And that is perfectly fine and it is also quite fun. However, it takes time. This means that we need a shorthand, something that will allow us to quickly ascertain what atom we are dealing with and what is going on inside the nucleus. This is where atomic symbols come into play. So let me bring in a general formula for an atomic symbol. And here it is. At this stage, you might be thinking, hold on, I think I prefer the colored spheres. What do all of these letters mean? Well, we need to unpack this general formula. So let's start with the giant X in the middle. The X stands for a chemical symbol of an atom. For example, I might be dealing with an atom of hydrogen, or maybe an atom of oxygen, maybe calcium, or possibly iron, or maybe even everybody's favorite, gold. Each atom, or each element if you like, has its own chemical symbol. For hydrogen, we are talking about capital H, for oxygen, capital O, for calcium, capital C followed by a lowercase a, for iron, capital F, followed by a lowercase e. You might be wondering, where does this Fe come from? Not all chemical symbols are derived from the English language. For example, Fe comes from Latin for iron. The Latin for iron is ferrum. Similar story for gold. The chemical symbol for gold is capital A, lowercase u. And this too comes from Latin aurum. Alright, so in an atomic symbol, the X will be replaced by a chemical symbol for a specific atom or element. What about A and Z? Z stands for the atomic number. And the atomic number equals the number of protons in the nucleus. Recall that it is the number of protons within the nucleus that determines the identity of the atom. So if I have a nucleus with 3 protons, I'm dealing with lithium, and if I have a nucleus with 6 protons, I'm dealing with a carbon. Alright, what about A? A stands for atomic mass number, and the atomic mass number is equal to the number of protons plus the number of neutrons that are present in the nucleus. Note that the chemical symbol does not actually give you the number of neutrons, but the number of neutrons can be calculated. I can subtract the number of protons from the atomic mass number. So in terms of a little equation, I could say that neutrons equal A, the atomic mass number, minus Z, the atomic number, which is the same as the number of protons in the nucleus. At this stage, you might be wondering about the electrons. Where do they fit in? Well, while we do not give the number of electrons in the atomic symbol, we can still deduce the number of electrons. Recall that when an atom is in its ground or neutral state, the number of protons equals the number of electrons. So let's say I'm dealing with a carbon in its ground state. Carbon has 6 protons, therefore it will also have 6 electrons. Alright, now let's look at a few examples. So I'm going to scroll down where I have prepared some examples earlier. Starting on the left, I have boron. The chemical symbol is B. The atomic number is 5, therefore I can say that I have 5 protons. How many neutrons are there in the nucleus? Remember, the number of neutrons is not given, but the atomic mass is, and the atomic mass is equal to the number of neutrons plus the number of protons, which means I can calculate the number of neutrons. I could say that the number of neutrons equals A minus Z. And I apologize, I do know that my Z looks a little bit like a 2. Alright, so in this case, I have 9 minus 5, and that will give me 4. So I can say that there are 4 neutrons. What about the number of electrons? Well, at this stage we are dealing with atoms in their ground or neutral state, which means the number of protons has to equal the number of electrons. I have 5 protons, therefore I have 5 electrons as well. I'm going to perform the same analysis for oxygen. So here is the atomic symbol, the chemical symbol is O, I am told that the atomic number is 8. This means that I have 8 protons. I have been given the atomic mass as 15, and I know that the number of neutrons is equal to the atomic mass minus the atomic number. So 15 minus 8 is 7, and I can say that there are 7 neutrons. The atom is in its ground state or its neutral state. The number of protons equals the number of electrons. So this atom also has 8 electrons. Alright, let's keep going and look at the iron on the right. So the atomic number is given as 26. This means that there are 26 protons. How many neutrons do I have? Well, once again, the number of neutrons is the atomic mass minus the number of protons. 56 minus 26 will leave me with 30 neutrons. And seeing how we are dealing with an atom in its ground or neutral state, the number of protons will equal the number of electrons. So I also have 26 electrons. Alright, so far in these examples I have been looking at analyzing given atomic symbols. But the situation might be slightly different. I might be given certain information and then told to create or to determine the atomic symbol. I am told that there is an atom of fluorine, and this particular atom of fluorine has 10 neutrons and 9 electrons. What is the atomic symbol for this atom? The chemical symbol for fluorine is F, so I'm going to write capital F. Now I need to figure out the atomic number and the atomic mass number. The atomic number is equal to the number of protons in the nucleus. I have not been given that, but I have been given the number of electrons. And if we are talking about an atom in its ground or neutral state, the number of electrons is the same as the number of protons. So the atomic number is 9. What about the atomic mass number? Well, the atomic mass number is equal to the number of neutrons plus the number of protons. Now I know that I have 9 protons. I've been told that I have 10 neutrons. 9 plus 10 is 19. So the atomic mass number is 19. And here is the atomic symbol for my fluorine atom. So in summary, an atomic symbol consists of a chemical symbol, an atomic number, which equals the number of protons, and an atomic mass number, which equals number of protons plus the number of neutrons. That is all for now, and I will see you on the flip side.